Thank you, Andrew. Typically, I kind of walk around a little bit when I talk, so start waving your hands if you can't hear me, if I get too far away from the microphone, but I'll do my best. So thanks once again for the invitation. It's a real pleasure to be here. And the title, as was just mentioned, is The Big Bang Ex Nihilo, ? Big Bang, of course, being our scientific understanding of the early universe, the physical origin of the universe that we live in. Ex nihilo, of course, refers to the doctrine of creation ex nihilo or de nihilo, which simply means from nothing. When God creates, he doesn't start with anything else. And then the question mark, because one of the questions of this talk is, what is the relationship, of any, between the scientific theory we have, the Big Bang theory, and this very old and central doctrine in the Abrahamic religions, creation from nothing. So I'll start in the first part of the talk going over the Big Bang, then I'll move into ex nihilo, and then kind of the question mark in the latter part of the talk, although the question mark will be present throughout. So here is the universe in one diagram, and what this shows is kind of the Big Bang picture, where the universe began in this extremely hot and energetic and dense state, and has been expanding ever since for almost 14 billion years. I don't have nearly enough time to kind of describe all these labels and explain all the really cool things in this diagram, but I want to make a couple of points about this diagram. The first point is that everything that this diagram depicts, we've known for less than 90 years, right? So this is really new knowledge in the history of human thought. And you can trace it back to this gentleman, whom I hope you recognize. In 1915, Albert Einstein published his new theory of gravity, which is called general relativity. And one of the first things that people tried doing with this new theory was using it to describe the universe as a whole. How does the universe as a whole behave under this new theory? And the two most important people who worked on this were Alexander Friedman, a Russian, and Georges Lemaitre, a Belgian, who was also a diocesan priest, as many of you probably know, but also a preeminent cosmologist in his day who rubbed shoulders with Einstein and Eddington and all the great scientists of the day. They were working independently, so they came up with the same solution to Einstein's theory of gravity for the whole universe independently. Friedman first in 1922, and then Lemaitre in 1927. And what they found was kind of unexpected. So at this point, everyone assumed that the universe was static, just basically sitting still. And what Friedman and Lemaitre found was that the natural solutions to relativity for the whole universe was that the universe shouldn't be sitting still, but it should be dynamic. It should be growing or shrinking. And incidentally, this kind of tripped Einstein up, because this is one of the first things Einstein tried to do with his new theory, was apply it to the universe as a whole, but he kind of got stuck because he thought the universe should be sitting still. Right? At any rate, they published these solutions. Nobody paid that much attention to them at the time in the 1920s, partly because they seemed so speculative and far from empirical verification. Georges Lemaitre unfortunately published in a Belgian journal that not many people read, so that didn't help with the dissemination of his work. But that all changed in 1929, which is when there was empirical evidence for the fact that the universe isn't sitting still. So Edwin Hubble in 1929 discovered two things. The first thing he discovered is that there are other galaxies. So the Milky Way is not the only galaxy in the universe, but there are these other groups of stars, like the Milky Way, that are really, really far away from the Milky Way. So you stop and think about that for a minute. We've only known that there are other galaxies since 1929, very recent. And then the other thing he discovered, and people had already noticed that these objects seemed to be moving away from us, and he verified that. These other galaxies are moving away from us, and the further away they are, the faster they're moving away from us. And that's called the Hubble-Lemaitre law today, after Hubble, of course, but also after Lemaitre, who actually wrote down the equation in the 1927 paper that predicted how the expansion would occur. And that was exactly what Edwin Hubble discovered. So now we know the universe is expanding, as general relativity predicts it should. And then a couple of years later, Lemaitre took kind of the next decisive step and said, well, what if the universe had a beginning? And he spoke about the universe beginning as a primeval atom. Kind of the history of the development of the Big Bang theory is a little bit complicated. On my last slide, I'll have an article by a historian of science who kind of traces out the history of the development of the idea, which is quite interesting. But Lemaitre is credited as being the so-called father of the Big Bang back to 1931. Interestingly, the term Big Bang didn't appear for almost 20 years. It's actually Fred Hoyle, who ironically never accepted the Big Bang theory, who gave it its name in 1949, somewhat pejoratively. Which is a good thing, because it's a much more catchy title than primeval atom theory. I don't think you could pitch a television series idea called the primeval atom theory and have it take off. So it's a catchy title, and it's good for that reason, but one of the unfortunate consequences of the name Big Bang is it makes you think of a bomb or a firecracker, which is not a great analogy for the Big Bang. Okay? Because what you imagine, or what happens with a bomb or a firecracker, is you have a whole bunch of matter concentrated at a single point in space, and then the explosion goes off and that matter travels out from that central point through space. But that's not what the Big Bang was like. Here's another example that you get pretty much in any introduction to cosmology. In this analogy, the universe is like a currant loaf, or like raisin bread. And the raisins are the galaxies, and the bread is space. Now, the raisin bread has a crust. We actually don't know if the universe is infinite, if the space is infinite or not. So you could imagine, this bread going on and not having a crust, just kind of peppered with raisins. And the way expansion works is like this currant loaf rising in the oven. And as it rises, the raisins all get further apart from each other. Right? But they're getting further apart from each other not because they're traveling through the bread, but because the bread in between them is expanding. Right? And it's just like that with the expansion of the universe. The galaxies aren't primarily traveling through space away from each other, but the space in between them is expanding. And so what that means is that there's actually no center, no unique center to the expansion. Because if you imagine choosing any one of these raisins, any one of the raisins is going to see all the other raisins moving away from it as the bread expands. And it doesn't matter which raisin you choose, they all see all the other raisins moving away. And the same thing in our universe. The fact that we see all the other galaxies moving away from us, from our galaxy, doesn't mean that our galaxy is special. If you went to another galaxy, you would see the same thing, because space is stretching everywhere. So the Big Bang didn't happen at a point in space. The Big Bang happened everywhere. The Big Bang is space everywhere expanding and then continuing to expand. And this is a really important point, that space and also time are part of the physical world. It's not as though, as Newton thought, and Kant in his own peculiar way thought, it's not as though space and time are kind of these a priori backdrops on top of which physics happens. But rather, space and time are part of the physical universe. And kind of the genius of Einstein's theory was that he was able to show how space and time behave in relation to matter and energy, and how matter and energy are affected by space and time. So it's all one physical reality. And that's something important to keep in mind as the talk goes forward. Okay, so I said I wanted to say two things that are interesting about this diagram. The first is how new this knowledge is to humanity. The second, though, is even though it's new, we understand a surprising amount about the universe in this diagram. And again, I wish I had the time to talk about all these labels and what they all mean. But we can actually describe how the universe works very far back, very close to the Big Bang. We have good empirical evidence that we understand how the universe was behaving like 2 minutes after the Big Bang. And we understand the physics that describes how the universe would have been behaving all the way back to a very small fraction of the first second. And we know this from particle physics, from high energy physics. We know how gravity works, and so on. However, at a certain point, at 10 to the minus 43 seconds after the Big Bang, this is the Planck time, for those of you who've done a bit of physics. Before this time, this very tiny sliver of a second after the Big Bang, we know that physics breaks down. The universe would have been so dense and so hot and so energetic that we know that our current theories of physics simply don't work. So we don't really understand how the universe would have been behaving in this first fraction of a second, if indeed this was the first fraction of a second. That's kind of the question. What really happened in this initial singularity, if indeed singularities are possible?
Would you like to get a quick question here?
Yeah.
Time. And we measure time by the vibration of cesium atoms in our civilization. What did you in the whole universe is the size of a cesium atom? How do you measure the passage of time at the very early points? Most cosmologists, they climb up at that point. I'm curious to know what you have to say.
I'm going to climb up for the time being because I want to think about it. But
okay.
Yeah. Right, so there is this question mark here, and this kind of inevitably leads people to kind of metaphysical questions. And namely, one of the questions is, if we have these question marks, do we need to explain it without physics? If physics kind of breaks down, and it is suggestive, at least, of a first moment in time. And so kind of the popular question you get, at least, or question that people seem to naturally ask is, well, do we need to explain what got everything started? Do we need God to explain why there was a Big Bang? So probably the most famous person who says yes is the philosopher William Lane Craig, who's also an evangelical Christian. And he's really popularized this so-called Kalam cosmological argument. He basically revived the classical Islamic tradition, thinking about cosmology and creation. And the argument basically says that anything that starts existing needs a cause, and the universe started existing, therefore it needs a cause, and as Thomas Aquinas says, this all people call God. Now Craig thinks that the best arguments for the universe having a temporal beginning are philosophical. So he's kind of in that tradition. He would be in the tradition of someone like St. Bonaventure, who thought you can have a demonstrative proof that the universe can't be infinitely old. But he also thinks that the science has a compelling convergence with this, that it really does seem that science also points to a beginning of time. And so he would say that science kind of seems to strongly indicate that the universe had a beginning, and therefore is really compatible with this idea of a creator. Naturally, though, there are other voices, and this is the great physicist Stephen Hawking, who died a few years ago. And he, towards the end of his life, he started speaking about how we don't need God to explain the Big Bang. And this is a quote from a popular book that he wrote with a fellow physicist, Leonard Mlodinow. And they said in this book, that came out about 10 years ago now, spontaneous creation is the reason there is something rather than nothing, why the universe exists, why we exist. It is not necessary to invoke God to light the blue touch paper and set the universe going. Okay, so if you're wondering what spontaneous creation is, hold that thought. I'm going to come back to that towards the end of the presentation. But notice this metaphor that he gives here. It's not necessary to invoke God to light the blue touch paper. I didn't know what blue touch paper was when I first read this, so if you're also from North America like me, this is the fuse of a firecracker is called blue touch paper over here. And so the metaphor is you don't need God to light the fuse to set off the Big Bang. So we kind of have these two different views about, do we need God to start the universe? Do we not need God to start the universe? But I want to take a step back and just remind you that we've only had this picture for less than 100 years. This picture where science seems to indicate that the universe, or science does indicate, I should say, that the universe is dynamic and that it's growing and that it was different in the past and that it seems to have begun in a singularity. We've only had this picture since the early 20th century. Before that, as I mentioned earlier, the widespread assumption was that the universe was static and unchanging, just kind of sitting still, right? And remember, that's kind of what tripped up Einstein when he first approached cosmology, because this was the kind of the worldview out of which he was operating. And so the question is, if this was kind of how people pictured the universe before Hubble discovered the expansion back in 1929, how did this doctrine of creation from nothing coexist with this picture of the universe? If your picture of the universe doesn't seem to kind of naturally have a beginning. And this morning from Dr. Silva, we all kind of got the answer to that. Namely, that the doctrine of creation from nothing isn't so much about a beginning moment as it is about the dependence of the world on God for its existence. Right? So we've already had an introduction to this, as I said earlier this morning, but I want to spend a bit of time walking through these 2 points that I've put up on the slide here. And if you're a biblical person like me, the first question you might ask is, well, isn't the doctrine of creation from nothing right there at the very beginning of the Bible? And doesn't the Bible say, in the first verse of Genesis, that in the beginning, God created the heavens and the earth, right? And that really seems to be describing creation as this initial moment where in the beginning God creates everything and everything appears, and that is creation. The issue with this is that, as many of you probably well know, this isn't the only way that you can translate the opening 3 verses of the book of Genesis. And in fact, most biblical scholars today think that this is not the best way to translate it. So here's typically how it's translated, not in all, but in many contemporary translations into English. When God began to create the heavens and the earth, now the earth was formless in emptiness, and darkness was on the face of the deep, and the Spirit of God hovered over the face of the sea. Then God said, "Let there be light," and there was light. So you can see this presents a somewhat different picture where you have this chaos, you have the formlessness, the emptiness, the darkness on the face of the sea, the Spirit of God hovering over the water, and then this process is initiated when God begins to create, and he begins the work of separation and populating the various realms of creation. For example, both contemporary Jewish translations, this is the New Jewish Publication Society, and New American Bible, NRSV. I don't think this is a bad translation. After all, the Septuagint translated it more or less like this, the Vulgate, some modern translations like the NIV. But the point is that it's not really there in black and white in an indisputable way in the first chapter of Genesis. Because really, the first chapter of Genesis, I would argue at least, it's certainly compatible with creation from nothing, but it's not trying to answer 21st century scientific questions, right? So it's believed that it reached its final form in the 6th century BC, during the time of the exile, when the Jews were in contact with Babylonian culture, right? And back then everyone was listening to Babylonian pop music and buying Babylonian blue jeans, and they knew the Babylonian creation myths. And the first chapter of Genesis is kind of written in that idiom, using the cultural tools of that time to express the faith of Israel in the God of Abraham and Isaac and Jacob. And so it speaks about God's oneness, it speaks about God's omnipotence, it speaks about the non-violent way that God creates, it speaks about the dignity of the human person. So it's kind of replete with theological truths about creation. But as I said, it's doing this in kind of a Babylonian framework that I think is perennial, but means that it has that context. And in fact, if you go and look through Scripture for references to something that looks like creation from nothing, you'll only find a handful of places, maybe as few as 2, that I've got up here. So the first is from 2 Maccabees chapter 7. This is where, this is the martyrdom of the mother and her 7 sons. And at one point the mother makes this statement of faith. Look at the heavens and the earth and see all that is in them. Then you will know that God did not make them out of existing things. So that kind of sounds like creation from nothing. Paul gives kind of a similar statement in Romans, talking about calling into being what does not exist. Again, scholars debate whether this is kind of these are deliberate kind of metaphysical statements that the human authors were making. But one difference here is that these were written later, so we're no longer in the 6th century, but now the predominant culture is Greek, right? And with a new culture come new questions, and now Jews and then later Christians have to start thinking about their faith in the light of the questions and the context of Hellenism, right? And there were a whole bunch of philosophies about cosmic origins that were floating around in the Greek world. And kind of in a longer version of this talk, I might kind of give a Cole's Note introduction to each of these. But when Jews and then later Christians started encountering these Greek ideas about the relationship of the universe to the divine, they encountered a number of things that gave them pause as biblical people. So for instance, in pretty much every Greek system of thought, matter just exists, right? Whether it's in Platonism, where you have the demiurge who creates, the demiurge has the receptacle there. Matter is a principle that exists independent of the creator. And each in its own way, the universe or matter is just there as an independent principle. That's a problem for the biblical God, because the biblical God is completely sovereign over everything, right? So the notion that something is outside of God's sovereignty is a problem for Jews and for Christians. Another problem is that in many of these accounts, creation is something necessary. So think of Neoplatonism, for instance, where creation kind of emanates from the one. So it's coming from God in a certain sense, but it's not God's free choice to create. It just happens. It's part of what it is to be divine for the world to come forth. And again, that's a problem for the biblical God, again, who is completely free, who's not constrained by anything. And then finally, particularly in kind of Platonic strands of thought, there's a problem with the view of the material world, that it's somehow flawed, it's somehow imperfect. You think about Platonism, the goal is to escape from matter, not to return to the resurrected body, as we heard from Dr. Kerr earlier today. Whereas the biblical vision, why would an all-powerful, all-good God create something that isn't good in of itself? And of course, the first chapter of Genesis affirms that goodness very, very forcefully. Okay. So these are kind of the issues that biblical people are encountering and realizing there's something not quite right with these Greek ways of looking at the world. So you can think of creation from nothing as a doctrine that's a response to Greek thought. It's biblically based in the sense that it's articulating the faith in the God of Abraham, but it's using no longer Babylonian language to express that faith, but now it's using the language of Greek philosophy, of ancient philosophy. And so creation from nothing says that God doesn't have anything when he starts creating. He creates even the matter, to use that philosophical term that I'll return to. He creates freely. He's by no means constrained in the fact that he creates or what he creates. And creation is good. And I've kind of listed here some of the important figures. Philo, the first century Jew, who was really the first to kind of really engage with Greek philosophy in an encounter with Judaism. He didn't quite get to creation from nothing, but by the time you're in the 2nd century, Theophilus of Antioch is really the first in a sustained, deliberate way to write about creation from nothing. The idea was probably already around by the time he came on the scene, but he's the one where we have it kind of written out. And then by the time you get to Irenaeus of Lyons, it's really central to Irenaeus' thought. He uses this notion of creation from nothing in an important way when he's writing against the heresies. So by the end of the 2nd century, it's really ensconced in Christian theology as a very central doctrine, and of course also in Judaism, and then later in Islam. So that apparently Moses Maimonides once said that this is the doctrine that's most common between the 3 Abrahamic religions, between Judaism and Christianity and Islam, this way of seeing the relationship of God to the world, that it depends totally on God for its existence. Okay, after all of that, so it depends on God, but it didn't have to begin, right? And isn't that really central to this notion of creation from nothing? Isn't it the case that there was nothing, and then at a certain point God created, and then there was something, right? And isn't that kind of moment of creation all important? Well, notice the way I just described it. I said, first there was nothing, and then there was creation, and then there was something. As though God is sitting there, and there's a metaphysical clock up on the wall that's ticking away, and at a certain point it reaches the 12 or something, and God says, okay, boom, now I'm going to create. And then after that time, there is creation. And the issue with that is that you have this metaphysical clock that exists independently of God. And one of the whole points of creation from nothing is that God is completely sovereign. There isn't anything that exists apart from God's will, right? So it's not as though God is subordinate to some flow of time within which he decides he's going to create at a certain moment, right? And Augustine, he wasn't the first to realize this, but he developed this idea in a particularly sophisticated and sustained way. And the way he articulated it is by saying, no, God is outside of time. And a nice analogy, I can't remember where I first saw it, but I think it's fairly widespread, is to think of a movie back when movies were printed on film. And you can imagine taking a whole movie and unrolling the whole spool so that you can have all the frames in front of you, and then you can see all of the frames all at once. And that's kind of like God's relation to the world. God lives outside of time, in his eternity, and all time is present to him, just like the person looking at the whole film that's unspooled. So from God's point of view, creation is a single, simple act, right? All of creation, in God's eternity, all of creation, all of space and time and everything in them depends on him. From our point of view, though, we're temporal creatures. So we're inside the movie. We're experiencing the world from frame to frame. So from our point of view, creation is happening continually in time. Each frame is held in existence. Each frame is willed by the divine creator. And so the key point here, and this kind of goes back to Einstein, is that time is part of creation, right? Just as space is part of creation. We fast forward a few hundred years. We've heard from this gentleman a few times already today. This is Thomas Aquinas, now in the 13th century. And in the 13th century, and a few hundred years before, there was this kind of raging debate about whether you could prove that the universe had a beginning or not. And there were Christians and Muslims and Jews all involved in this debate, some saying you could prove the universe has a beginning, others saying you couldn't prove it, that it's actually eternal, someone like Avicenna. Thomas, though, was in kind of the third camp, and after Thomas, this became more or less the default view, that you can't prove it one way or the other, that you actually can't do a philosophical demonstration that the universe has a beginning or that it doesn't have a beginning. He took kind of the agnostic position. That being said, he thought the universe did have a beginning. He just thought it was something that had been divinely revealed, not something that human reason could arrive at. But the point here, and this kind of drives home kind of this central aspect to creation from nothing. Thomas says if God had wanted, he could have chosen to create a universe that didn't have a temporal beginning. Well, why? Because the real essence of creation is that relation of dependence, as we heard this morning. So that's why Thomas Aquinas and Avicenna, Avicenna believed that the world was eternal. but he had, in a certain sense, he had a similar notion of creation, because what was important was that relation of dependence. And kind of a key point that Thomas makes is to say that creation is not a kind of change, right? And that's the way we kind of almost perforce have to imagine it. What we do, at least what I do, is you're imagining nothing as though nothing is something, some kind of blackness, and that changing into something. And even the way we say it, something from nothing, makes it sound like a process or a change. But Thomas says, no, you're imagining that, but you have to be careful, because conceptually that's actually not what's happening. Nothing isn't, a change is where you have some kind of substrate that enables something to be in one form or in one configuration at one time, and then in another configuration. But if you don't have anything, you can't have any process or change. So what it really is this dependence. Okay. So I don't think this is a very helpful way of thinking about the relationship between physical cosmology and creation. Maybe this is a better way of framing the question. Do we need God to explain why there is something rather than nothing? And here we'll get back to our friend Stephen Hawking and Leonard Mlodinow. And I promised you that I would talk about this thing they called spontaneous creation. So they say spontaneous creation is the reason there is something rather than nothing, why the universe exists, why we exist. What do they mean by spontaneous creation? And around the same time this book was written, there was another popular book by Leonard Krauss, also a physicist, A Universe from Nothing. And he says, quote, "Our current understanding of the universe, its past and its future, make it more plausible that something can arise out of nothing without the need for any divine guidance." And then in the afterword, Richard Dawkins says, "Even the last remaining trump card of the theologian, why is there something rather than nothing, shrivels up before your eyes as you read these pages." Okay. Why are they so excited about this notion of spontaneous creation? They're kind of different versions of it. I'm going to explain, or attempt to explain, one of them. Sometimes you'll hear about quantum creation. That's kind of getting at the same thing. But I'm going to explain a version that speaks about spontaneous creation. And this is kind of analogous to a well-known physical phenomenon, which is spontaneous particle creation. So it turns out that there's no such thing as what you might imagine is a pure vacuum. There's no such thing as absolutely empty space. You always have particles appearing and disappearing in space. And that's not science fiction, that's well established. It's well understood through quantum mechanics. It's been empirically verified. That's just the way the world is. And it's happening in this room. Particles are appearing and disappearing all the time. If you want to know more details, you could ask Father Andrew, perhaps, who's a real particle physicist. But basically, the idea is, well, what if the universe, what if something similar happened in the origin of our universe? Alex Vilenkin developed this idea back in the 1980s and kind of asked this question: what if the universe, complete with space and time, tunneled from nothing, spontaneously appeared from nothing? So the idea here is that there's a more fundamental quantum level of reality that isn't spatial or temporal. And that kind of like, now of course these particles appear within space and time, but kind of by analogy, just as these particles can appear in space and time, what if a universe complete with space and time and matter and energy emerged spontaneously from this more fundamental quantum state? Right? And it sounds kind of crazy, and in fact, in one of his initial papers, he actually says something like, I can't remember what the exact words are, but something like spontaneous creation is a crazy idea. This is in a refereed scientific paper. What he does is he goes on to write down some equations and show a framework in which it actually doesn't sound completely implausible. So I want to stress here that this is a very speculative idea. These kind of quantum cosmologies, we don't know the physics well enough to kind of adjudicate, whether this will hold water. But the point is that a lot of physicists think that it's at least plausible that something like this could happen. And that's what people like Hawking and Krauss kind of run with, right? Because, if creation from nothing claims that God creates matter, here we have a scientific theory that claims that, science can say what the origin of matter and energy and space and time is. And I think this is kind of Stephen Hawking's basic argument. Physics explains everything about the universe, or we hope that physics can explain everything about the universe, even where space and time and matter and energy come from. Therefore, God is superfluous. God is supposed to be the one that creates the matter, but maybe we can explain that using physics. Okay. The problem is how we conceive of this notion of matter. And I'm glad earlier today we had talk about matter and form. Because when this doctrine of creation from nothing was formulated, it was formulated in the context of ancient philosophy. And the way they understood matter is not exactly the same way that we understand matter today as kind of modern scientific people. So I have this image up here, because often in Philosophy 101, if you're learning about matter and form, one of the stock examples is to imagine a statue of Socrates made out of bronze, right? And you're told the matter is the bronze, and the form is the configuration of the bronze, or the shape. The problem with describing it like that is that immediately as modern people, we hear that and we go, okay, the matter is the bronze. Aha, I know what that is. It's atoms, right? It's molecules. That's what matter is. But that's not really the way that they conceived of matter. For someone like Aristotle, matter is what underlies a process or a change. Remember, I was talking about change earlier. So if you have a change, matter is what the constant is in that process. You go from situation A and you change to situation B, but the matter is what makes that transformation possible. So just to give a concrete example, if you imagine casting a statue like this, you might start with bronze in the form of Ignatz, like this, and then you cast it into the statue, and now it's in a different form. So you have one form and then a second form. That's what's changed. But the bronze is what makes that change possible. The bronze is what underlies that process. If you think of a different process, though, so bronze is an alloy of copper and tin. So think of this process now of taking copper, native copper and native tin, and you do some kind of metallurgical thing that I don't understand, and you get this alloy of bronze. So if you think of this change, now bronze is a form, right? Bronze is the final form of this process. The matter is the copper and the tin, which start kind of in a configuration where they're separate, and then they end up in the configuration where they're in this alloy. So in this process, bronze is a form. In this process, bronze is matter, right? So if you're going to go to Aristotle and say, tell me what matter is, he would say, well, that doesn't really make sense. What do you mean, what is matter? What process are you talking about, right? Let's examine the change of the process, and then we'll identify what the substrate is, what the grounds of possibility for that change are, and that we can identify as the matter of that process, right? So this isn't to say that we're using the word matter wrong, in the 21st century. It's a perfectly legitimate way to use the word matter, but we just need to be attentive to this difference in how this term is used. And if you think about this, universe emerging from kind of this more fundamental quantum state, obviously, that's a process in some sense of the word, but obviously the matter of that process is not atoms. It's not kind of stuff as we know it, but there is some constant. There is something that enables that process to occur, which would be the underlying quantum reality, right? And Alex Vilenkin actually, unlike Hawking and Krauss, I think got this. So he wrote a popular book a few years ago called Many Worlds in One, and these guys will talk about the universe coming from nothing, but he says, quote, the state of nothing cannot be identified with absolute nothingness. The tunneling, or the emergence, is described by the laws of quantum mechanics, and thus nothing should be subjected to these laws. The laws of physics must have existed even though there was no universe, right? So we don't have a universe as we know it, but the laws of physics are describing some reality, right? And he's just pointing out what I think is fairly obvious if you think about it a little bit, that you can't call that nothing, even if it's a type of physical existence that would be very alien to us, because it would be atemporal and aspatial and wouldn't have mass and energy in the way that we know it. As Vilenkin says, it's not, quote, absolute nothingness. I just wanted to give a tip of the hat to Lonergan, who's helped me to kind of think through these things, but he kind of points out that as moderns, we kind of get tripped up by this notion of matter. We kind of identify the real or reality most fundamentally as matter. And I won't kind of dive into what he's saying here. As I said, I just want to give a tip of the hat. But he'll use the language of potency, largely, I think, to avoid this confusion that we have with the term matter. So this is what creation from nothing is saying. God isn't just a designer or a demiurge who's working with pre-existing possibility. It's not as though there's a quantum state already there and God comes in and lights the blue touch paper, as Stephen Hawking says. If this framework of a universe tunneling in this quantum way, if that ends up being true, that does happen spontaneously, right? But what creation from nothing would explain is where that quantum reality came from to begin with. So God is the explanation, or God gives existence to the very grounds of possibility for physics to happen at all. Okay. So I want to finish by returning to this argument of Stephen Hawking. And the first sentence there I actually find kind of exciting. Like, wouldn't it be amazing if we could actually, with physics, describe even space and time? What if there is a more fundamental level of reality out of which space and time emerge, and if we could explain that, physically with equations, that would be incredible, right? And that's kind of the goal of the natural sciences, is to explain everything you can about the physical world. Right. What's kind of interesting is that this argument he makes is not by any stretch of the imagination original. So we heard earlier today that there's only one article in Thomas Aquinas about the existence of God. But if you've read that article, you might remember that Aquinas can think of two reasons why there might not be a God. The first is the existence of evil, the presence of evil. That's a whole other lecture. But the second reason is essentially what Stephen Hawking is saying. So Thomas says, it's superfluous to suppose that what can be accounted for by a few principles has been produced by many. But it seems that everything we see in the world can be accounted for by other principles, supposing God did not exist. For all natural things can be reduced to one principle, which is nature. In kind of contemporary language, one way you might re-express this last sentence is to say all physical things can be reduced to one explanation, which is physics, right? And if that's the case, then why do we need to add God into the equation? Okay. Well, the answer is that physics doesn't explain, nature itself causes natural things as regards their form, but presupposes matter, right? So, in more contemporary language, physics explains physical things as regards the processes and the configurations and the intelligibility, but it presupposes matter. It presupposes the underlying substrate or the grounds of possibility for physics to actually occur. So I'll finish there. I'll leave up this slide, which kind of has some of the sources that were in the talk. Just briefly to point out a couple of them. This is the article that talks about the origin of the Big Bang Theory. Here's where the relevant stuff is for Augustine and Aquinas. These are the popular books by these physicists I was referring to. They're actually like good readable books if you want to learn about popular science and these speculative ideas. So I do recommend them for the science. I certainly though take issue with the metaphysics, at least in the Krauss and the Hawking book. The Vilenkin book, I actually haven't read the whole thing cover to cover, just portions of it. And then if you're interested in kind of the notion of creation from nothing, these are a couple of relatively recent volumes that are collections of essays. I have an essay in this second one that has some of the ideas I have in this talk and other ideas about the relationship between cosmology and creation from nothing. But thank you for your attention. I look forward to your questions and comments.